Okay, so here we are in the second section in Chapter 7, and what we're going to be doing now is looking at how we multiply and divide rational expressions. And before we do that, let's recall something. So going back to rational numbers, if you remember, if we have something like 18 over 27, let's say, times 12 over 45, so we're multiplying here, we want to simplify. And so one of the things that we can look at is common factors. 9 goes into 18, 2. 9 goes into 45, 5. Let's see here. 3 goes into 12, 4. And 3 goes into 27, 9. And so this simplifies to 8 over 45. Right? Pretty simple. How about division? If we have 16 over 27 divided by 12 over 18, do you remember what the first step always is? Hopefully you do. It's 16 over 27 times the reciprocal, 18 over 12. And now we do the same kind of thing. Let's use 4. So 4 goes into 16, 4. 4 goes into 12, 3. 9 goes into 18, 2. 9 goes into 27, 3. And so this simplifies to 8 over 9. And it's the same exact procedure when we're dealing with rational expressions. And the whole key there is factoring completely and then getting rid of common terms. So let's look at some examples. Okay, so this looks pretty interesting, pretty challenging. I probably should use parentheses here whenever possible to make very clear what we're doing. And so what we want to try to do now is factor everything as completely as we can. So why don't we do this? Why don't you look at this problem with a piece of paper, press pause, and try to factor the tops, because the bottoms are already simplified. And let's see if we agree. Okay? Catch you in a second. Okay, I hope you got this. And so now what we look for are terms that we can simplify. And so we can cancel the x minus 7s. We could cancel an x plus 5 and an x plus 5. And so my final answer on this one is just x plus 1 times x plus 5. And it's absolutely fine to stop right there. There's no reason to multiply that out. Okay, let's try another one. Okay, so here we go again. And this is a problem. Oh, I forgot it. Let me just take a second. I knew that was a little too easy. So this one looks pretty complicated. And let's do the same thing. Press pause and try to factor it completely yourself. And let's see if we agree. Okay, so take some time and see how well you can factor the tops and the bottoms. Okay, hopefully you got the same thing here. And so now we just cross out all the common terms. There's 1. We can go like that. There's 2. There's 3. Oh my goodness gracious. And there's 4. So what does this equal? 1. How cool is that? Okay, now let's look at division. Okay, so here's a fairly, at least it looks complicated expression, division of two rational expressions. And remember, the first step here is always to change the division to multiplication and then to simply look at the reciprocal of this. And so I'll rewrite this exactly the way it should be rewritten. Okay, you got that? That's a really pretty simple step. Division becomes multiplication, and here we just write the reciprocal. So once again here we want to factor completely and look what we can cancel. And as I've asked you a couple times, see if you can do this work on your own, and we'll see if we agree. But I just want to point out before we do that, once you take the division problem and make it multiplication, that's it. So really, the division problems are just the same as multiplication once you take the reciprocal. Okay, here we go. So here's what we get when we factor everything completely. And now we just want to get rid of all those common terms. So a 6x squared and a 6x squared and an x plus 8 and an x plus 8 and an x plus 3 and an x plus 3. And so our final answer is x plus 1 over x minus 3. And when you go back and you look at the original problem, right there, this certainly is a lot simpler looking than the original one. Alright, so that's it for multiplying and dividing. And we'll come back and we'll look at the next operations. See you then.